Hey, what's up guys? Welcome back to another video in the Spigot series. In this video, I'll be teaching you more about OrmLite and how to set up relationships in SQL databases. Alright guys, welcome back. So in the last video, I showed you guys how to use OrmLite, which is a library that allows you to interface with a SQL database really easily within your Minecraft plugins. And I already made an episode where I showed you guys the basics of OrmLite, how to set it up for the first time with your Minecraft plugins, and how to use it within SQLite database. So I'll be doing the same exact thing in this episode, but a little more complex. So if you haven't seen that episode, make sure to watch that one before this one. You don't have to, but I think it'll be very helpful so you can see some of the stuff that I'm going to be skipping over and also understand what's going on. So as you saw, OrmLite allows you to really easily interface with your SQL databases and really abstracts a lot of the stuff that you have to normally write if you were to use something like JDBC directly and actually write your own SQL queries manually. So we get to do it now via objects and via methods and stuff like that instead of having to write SQL queries ourselves. So it's just a much more simplified process. So now I'll be showing you some of the more complex things that you can do with SQL databases and how to do them with OrmLite specifically, okay? So what I'll be teaching you about right now is called relationships, which put simply is a way of connecting tables to one another. So what I'll be doing is making a plugin here that shows you how to build those relationships using OrmLite, how to use them on a basic level, and create services for those database entities and all that fun stuff and those tables. But before we jump into actually coding the plugin, I'm going to show you guys, the different relationships within SQL and how to actually do them, how to actually, make a relationship between two tables within SQL before we actually see how to do it on a high level. Because when we're actually using OrmLite, it's going to handle all of that for us, generally speaking. But I think it's good to know behind the scenes what is happening with SQL itself. Okay, so let's jump into that first. Alright, so I got this website here, I'll link it down below, but this is a really nice website that shows the different relationships that you can do within SQL databases. The three types is a one-to-one relationship, a one-to-many relationship, and a many-to-many relationship. Let's go and start with the one-to-many relationship. This is, I think, the most easy to understand. So in SQL, the way that you actually create a relationship is by using something called a foreign key. So within a regular table, you have your ID, right? And this is the primary key, so this is how you identify the record within the table. But if you have a foreign key, this is simply having another field within a record that stores an ID of another table. So if I, for example, want to have two tables, employee and address, if I want every employee to have an address, then what I would do is go into the address table and I would add a new column within that address table called employee ID. So then we're going to store within that a foreign key because it's foreign because it's another table, and that foreign key is going to be the primary key of the employee table. So now whenever I create an address and it has an employee ID, that employee ID is going to reference some employee within the employee table because that's the primary key of an employee. Okay, so hopefully that makes sense. Using a foreign key within a table is how you can reference another table and therefore create a relationship, okay? And so that's how we come up with these three relationships, the one-to-one, one-to-many, and many-to-many relationships, all right? So one-to-many, what that means is that whenever you have a single record within a table, it can have multiple relationships with another table. So for example, the one-to-many relationship here would be that an employee has multiple addresses. So the way that that's achieved is because since the address table has an employee ID column, this can be anything. It can be one employee, it can be another employee, but each of these addresses are going to have a single employee that they're tied to and it has a relationship with, but there's going to be a bunch of different addresses in the table, right? And each of those addresses could be tied to the same employee. So you could have two addresses that reference the foreign key for the same employee, okay? So what I mean is that you could have multiple addresses in the same table that reference the same employee ID. So this means that they all have a relationship with the same employee, and therefore this is a one-to-many relationship because this single employee has many addresses, all right? And again, the reason it's one-to-many is because the employee ID doesn't have to be unique. Every address can share the same employee if they really wanted to, and that depends on how we define our database schema. If you want to, you can make it so that the employee ID has to be unique. And this is done with a one-to-one relationship. So it's actually the same exact thing, pretty much up to a point where you have this employee and then you have another table that references that employee with a foreign key. So in this case, we still have our employee table, but we also have a employee details table. And this one has the employee ID column, right? But in this case, you can see that it's a PK, a primary key, not necessarily a foreign key. So in this case, it's actually kind of both. And this is because instead of having its own ID, it's just going to use the ID of the employee that it's tied to. And that makes it so that it's unique. Every employee details record within the employee details table is going to have a unique employee ID, because if you remember, two records within the same table cannot share the same primary key. So in this case, it's both a foreign key and a primary key. It's a primary key because it's the ID of the table, and also it has to be unique, but it's a foreign key because it references another table. So this enforces and creates the one-to-one relationship, because there can only be one employee per employee details, in the same way the other way. So it can go both ways. So hopefully that makes sense between one-to-one and one-to-many. The main difference is that the column is unique for one-to-one, meaning that every employee details record within the employee details table has to reference a different employee than the other records, okay? All right, so now let's take a look at the last relationship within SQL, which is a many-to-many relationship. So in this case, we have a users table, we have a books table, and we have a checkouts table. So what we're trying to achieve here with the users in the books table is allow a single user to be able to check out multiple books, or none if they want to, but we also want a single book to be able to be checked out by multiple different users potentially. So in this case, it's a one-to-many relationship, but in both directions. So it's a many-to-many relationship because the users table needs to be able to reference multiple books, but also the books table needs to be able to reference multiple users. So the normal way that we do a one-to-many relationship would not work here. So what you do instead is create something called a join table. So a join table simply contains the foreign keys of both the tables that you're trying to create a many-to-many relationship for. So in this case here, we have a foreign key for user ID and a foreign key for book ID. And as you can see here, the arrows show the relationships with the other tables. So we have the foreign keys for the user ID being tied back, and then we have the foreign key for the book IDs being tied back this way. And so this just illustrates how they're connected into one table. So this one table here establishes the relationship between a single user and a single book. And you can actually have multiple references of those users having different relationships with different books. So for example, if we look closely here, we can see that the same user, user1 with an ID of 1, has a relationship with multiple different books, so 1 and 2. So that would be a simple one-to-many relationship, right? Because the same user has a relationship with multiple different books. And then over here we see for book ID, we have 2 and 2. So that's book 2, and book 2 has a relationship with multiple different users. So that's very interesting. That's also a one-to-many relationship in that direction. So since they can both do that, it's a many-to-many relationship. And hopefully that just makes sense now. So having this join table here allows that to be done. Hopefully that makes sense. And it establishes that many-to-many relationship. But you can also provide other, information in that table if you want to, because it doesn't make sense to store the checkout date necessarily in the users table or the books table, because a book can be checked out by multiple users, so it wouldn't make sense to store that checkout date in a single book or in a user. So that doesn't really make sense to go there, but it makes sense to go into the join table itself, because each record in the join table represents a single checkout between two different users and books. That relationship has been tied together, so storing that data with that join table makes sense. Hopefully that I'm explaining that good enough, but a lot of the time you will see just the join table having just the foreign keys of the two tables and also the primary key, but you can also store other information with it as you see here as well, okay? Alright, so now that we understand the three relationships within SQL and how to do them using foreign keys, now I'm going to show you guys how to actually code a plugin that uses all those relationships. Alright, so before we begin coding here, in our pom.xml I set it up already so that it has SQLite imported as well as OrmLite for JDBC, so for Java. And then also I added the plugin that compiles the plugin directly into the plugins folder from our test server. So these are the two important things. Make sure you have these, OrmLite, and then also a database JDBC driver. It doesn't have to be SQLite, but it can be whatever database you like to use, like MySQL or Microsoft SQL Server, whatever you want, okay? Anyway, so the first thing I want to do is actually just create our packages so we know exactly what we're going to be doing. So some of the obvious ones is commands, listeners, and then we're going to have a database package, so database, and then we're going to have a entities package, entities, and then finally we're going to have something called a services package. Alright, so in the database package, what we want to do is create a new Java class. We'll just call it database, but you can call it whatever you want, whatever makes sense for you. And within here, this is where all of our connection stuff is going to live, like we did last episode. So this is where we're going to establish the connection to our database via JDBC, and then do some of the other stuff like create the tables and create the DAOs and all that fun stuff, okay? And here we go, here's the connection that we've made to the database. So at this point it should be connected. If not, it's going to throw an exception, which will just pass upwards. And now inside of our main plugin class, we can go ahead and actually instantiate this database class into an object and set it up that way. And now we're going to make a try and catch, and then we're going to ensure the plugins data folder exists. So if get data folder dot exists. So if the data folder does not exist, meaning that the plugin folder itself does not exist, we want to go ahead and create it. And then after that, we can assume it's created successfully. So we're going to actually create the database connection. So we're going to do database is equal to new database, and then we're going to pass in that string. That's what it wants, right? So the string here is going to be the location of our database. So in this case, since we're using SQLite, it's just going to generate a database file that we can just provide the path for. So we're going to do get data folder again, dot get absolute path, and then we can append that path and do database.db. So this is going to be the name of our database, and then .db, the type of file, okay? And then we're going to catch any exceptions. So we're going to do exception e. So pretty boilerplate code right now. We've done this last episode, but I just wanted to do it in front of you again just so you can see. But now we can actually begin setting up our tables and creating the actual entities that will represent the data within our plugin, and do all that fun stuff, okay? So the first relationship that I want to show you guys is actually going to be the one-to-many relationship. And the way we're going to illustrate that is with a guild object and a player object. So a player can be part of a guild, and then a guild can have multiple different players within it, right? So that would be a one-to-many relationship because one guild can have many different players, right? And then one player can be part of only one guild. And if you were to code this, just using SQL yourself instead of using a library like OrmLite, the way you would do that is just by having a column within the player table called, guild ID. It's a foreign key that references the guild that the player is part of. But since we are using a nice little library here, it makes it way easier for us. We don't have to worry about having to code all that out and use SQL actual syntax to worry about how to do that. We can actually just write it using Java code and it'll do all the magic for us if we do it right. So we're going to create a new guild class, and this guild class is going to be a database table, and then we can give it a table name of guilds. And then pretty much every table will, for the most part, need an ID. And so we're going to do private integer ID, and we're going to have this annotated as a database field, which is just really a column in a table. So database field, and this is going to be a generated ID, so that every time we create a new guild within the table, it's going to automatically generate an ID for us. We don't have to worry about populating it ourselves, which is very nice. So what are the other things that a guild is going to have? We can have a private string name. So the guild has a name. The guild might have a tag, like a clan tag, so like poop or something like that. Private string description. That's also something that makes sense, I think. And so now we can go ahead and annotate these as well. So database field. And if you want to see all the attributes you can do, you do Control P, or it should automatically pop up. There's a bunch of them to choose from, but the one we want to do is can be null. Can be null. We want to set it to false. So this means that whenever you create a new guild record within the guilds table, there has to be a name, or else there's going to be an issue. There's going to be an error because that's invalid. So establishing as can be null means that every time you have to create a new guild, there has to be a name. All right. So for the other ones, we don't really care. These can be null. So we're going to do database field can be null is equal to true, which is the default, but I think it's important to just have it there anyway to show you guys how it works. So all that means is that whenever you create a new guild, these can be null. These don't have to have values within the table initially, okay? And then now that we created this table here, every table is going to need a noargs constructor. So you can do code, generate, constructor, unselect everything, click OK. There we go. And then now we also need getters and setters. That's very helpful to have for when you're working with the objects. So getter and setter, select everything, click OK. So now that we have the guild table, let's go ahead and create the other table, which is the player table. But since player is already a thing within Bucket, we're just going to call this one guild player, just to make it less confusing when we're importing stuff via code. So this is going to be another database table, but the name is just going to be, instead of guild players, it's going to be players. All right, so this one's going to need a primary key as well. So private string UUID. As we saw last time, we can just use the UUID of the player object within Bucket just as the ID for the player in the table as well, which is very nice. So this is going to be a database field, And instead of having a generated ID, this is not going to be generated, we're going to actually provide it. We'll just set it to ID is equal to true. So that will tell it that that is the primary key, that's the ID of the table, but we're going to be providing it ourselves in this case, all right? So now what else does a player have? We're going to have a name. That's something we could have if we want to. So now let's go and see how we can create the one-to-many relationship, right? So again, just as a reminder, a single guild can have multiple players within the guild, all right? So essentially what we would, ideally want to do with our database table is to have a list of players. But of course, SQL does not support like a list or an array or anything like that. That's not really how it works. So what we do is go to the other table, and then within this table, since a player can only be part of one guild, we can simply have a foreign key to guild. And that makes sense, right? Because since a guild player or a player can only have one guild that they're attached to, it makes sense just to have one column or one field that can be, null or the ID of the guild that they're part of. So what we can do here is do private guild, all right? So the reason we're actually providing the guild object itself instead of the actual, foreign key ID, the actual ID of the guild table, is because since we're using OrmLite, it abstracts that for us. It'll actually do all that behind the scenes when it creates the table for you. So all we have to worry about is just setting the annotation properly, and then we can just use the actual field directly and use the object directly, which is very nice, okay? So this is why you would want to use a library like this. So we're going to do database field, and so this is a foreign field, so foreign is equal to true, because it's referencing another table. And then what we want to do is do foreign auto refresh is equal to true. And then we're going to do a column name. This is optional, but we're going to set it ourselves. We're going to set it to guild ID. So this is going to, behind the scenes, create a guild ID column, which is going to have a foreign key to the guild table. All right. So this option here, the foreign auto refresh, what this will do is every time we actually obtain a guild player or a player within our Java code from the table, it's going to automatically provide the guild as part of that object. It's going to automatically grab it from the other table and then join it into that, guild player object, so we can just have it readily available. We don't have to do another query to, first grab it and then link it to this one and then have to worry about, doing anything like that. It's just going to do automatically for us, okay? So that's actually all we have to do to create the one-to-many relationship between the guild table and the guild player table or the players table. Let's just create this other field that has a foreign key relation, all right? But one thing you can do, which is very, very helpful, is that inside of this guild class, since we have the magic of OrmLite, we can do something called foreign collection field, and then we're going to do the foreign field name. So this is going to be guild. So now we can do private foreign collection, and then for the type we're going to do guild player, which is the other table or the other class, and then we can give this a name, whatever you want. We can call it members. Okay, so what this is doing for us is whenever we get a guild from the guilds table, whenever it has any members within that guild via, the relationship that we've built here, we'll have this field here that enables us to actually grab a list of all the guild players that the guild has a relationship with. So it's not a list, but it's something similar to a list where you can actually just loop through every member or every guild player that the guild is, has a relationship with, right? Since it's one-to-many, like I said before, it can't really store an array or a list using SQL, but since we are using OrmLite, it actually helps us out and lets us grab a list of all the guild players. So that's very nice. So what this refers to, the foreign field name, is actually just the field in the other table that, establishes the relationship. So this happens to be guild. So behind the scenes, OrmLite will be like, oh, okay, we have a relationship, a foreign key already set up on the guild player table. And so this is a one-to-many relationship. So on the guild table, or on the guild class rather, because this is happening on a, Java code level, it's going to enable us to provide, a foreign collection for us to work with. So whenever we get a guild, like I said, it's going to also allow us to get the members of that guild automatically. Oh, by the way, it looks like I created the guild class and the guild player class in the wrong package. We want to move it from database into entities. Here we go. So now let's go back to the database class, and what we want to do is actually create the tables for our classes that we've created. So using the connection source, we can do table utils, which is part of OrmLite. So table utils.create table if not exists. Pretty self-explanatory. So connection source, and then now we can just simply provide the actual class that we want to create the table for. So guild.class, import guild, and then the same thing for guild player. So table utils.create table if not exists, connection source, guild player .class. So you can think of this as not only creating the table, but also registering our class that we've annotated here with OrmLite, so it can do its magic, all right? So create the tables. And so after this, what we also want to do is create our DAOs, which is our data access objects, which is how we interface with the database once we have that connection established and the tables created. So private final DAO. And so the first one you want to provide is the actual class that you're trying to create it for. So this is going to be guild. And then the second thing you want to provide is the type for the primary key. So for guild, the type for our primary key is an integer. So instead of int, since that's a primitive, we want to do the object version of that, which is integer. And we can say guild DAO or DAO. And then we also want to make one for guild player. But guild player has a primary key, which is string for the UID. So we want to do it as a string instead. So now it's complaining just because it's final and we have not given it an initial value. So within the constructor here, we can go ahead and create the DAOs. So we can create a DAO by doing guild DAO is equal to DAO manager, which is from OrmLite obviously, dot create DAO, pass the connection source, so the connection to the database. And then now we can also provide, and just like before, we can also provide the class itself, so guild dot class. There we go. And then we'll do the same thing for player, so player DAO is equal to DAO manager dot create DAO connection source guild player dot class. All right, there we go. So now we've created our DAOs, and we can then use these objects here to interface with the database. So create new guilds, update guilds, query the guilds table, all that fun stuff. And so what you could do is create new methods within this database class, and have it interface with these DAOs here and do all the fun stuff with the database. Or you can create a service layer, and the service layer is going to have all the business logic of what you want to do within your plugin, okay? So the service layer is going to be the thing actually using the DAOs to interface with the database. And so what that does is, creates a separate layer of abstraction upon the actual stuff that you want to do and keeps everything separate into its own little place. So in this case, we create all of our basic database stuff within the database class. And then within our service layer, we can interface with our database layer, which is really just this one class, to actually do what we need to do, okay? So I'm not really a stickler on design patterns and stuff like that, but that's just a small thing that you can do to give your plugins a little more structure, all right? So I recommend doing something similar to this at the very least, all right? So within services package, we're going to create a new class. This is going to be called the player service. It can be called guild player service, but player service works as well. This is going to have the business logic or just the actual logic of our plugin for anything that we need to do with the player. So what we can do is we can do private final, and I know we just did this, but we can do private final DAO guild player string player DAO. And what we can do is actually just pass this in when we create the service so that we can just use this directly within the methods of this class itself. So for example, if we want to create, within this player service, a way to create a new player within our table, we can do something like public guild player create guild player DAO. So the player DAO is how we interface with the database. So player DAO.create player, and then we can do return player, catch exception e.print stack trace, and then return null. All right, so hopefully you understand what this does if you watched last episode, but what this will do is take a guild player that you provide, attempt to create a new one, and what this will do behind the scenes is actually populate the ID, the primary key field, which is this one here. And then if it worked, if it passed that without throwing an exception, we're just going to return it, and we can see if it's null or not to know if it worked. So if there's an exception, we're just going to print the stack trace and then return null. There's different ways you can handle that, of course. You can rethrow the exception so that you can handle it within wherever you're calling this, or you can return true or false to know if it worked. There's many different ways you can handle that sort of logic for exception handling, okay? So now we need to create this player service so that we can actually use it somewhere within our plugin, right? So we're going to go back to relationships, and this is where we can just create that if we want to. So just like we only have one instance of database, this is what you call a singleton. There's only one instance of it because we want to make sure that there's only one connection to the database and that everything is just, within that one class and then conflicts. We can also create a singleton for every service that we have as well. That's a very common practice when you're creating applications such as this, all right? So private player service, and then now we can instantiate that down here. So create our services. So player service is equal to new player service, and now this is asking for the DAO, right? So to get the DAO, we can do something like database.get, player DAO, whatever it's called, but we don't have that method yet. So let's go back here and do code, generate, getter. We'll do it for both guild DAO and player DAO. Okay. Now back here, we can do database.get player DAO. So now we are taking the DAO instance from the database class and passing it into the player service class so that the player service class can interface with the database and do what it needs to do. All right. So here's some of the other methods that you could have within the service potentially. You can have, whatever you want, but some of the other common things that you may want to do is find a guild player by the UUID. So you can pass in a UUID. It's going to query for the ID. If it can find a player within the players table with that UUID, it's going to return it. Otherwise, it's going to return null. And then for update, you can pass in a guild player. It's going to call player DAO.update. It's going to update the fields that need to be updated and then return the new updated object. And then for exists by UUID, it's very similar to the other one here. It's going to pass in a UUID. It's going to check to see if it exists based on that ID. If it does, it's going to return true. If it doesn't, it's going to return false. Now let's go ahead and create a guild service. So this will be handling everything related to guilds. So since our guilds deal with both, the guild themselves and the players within those guilds, we're going to actually bring in the DAO for both of those tables. So we're going to do private final DAO guild integer and then the player DAO. So let's go ahead and create the constructor for that, just like before. And so within this service now, we can do anything that we want to do for, what business logic we want to do related to, creating guilds, updating guilds, grabbing players from a guild, anything that we want to do related to a guild, we should keep within this class, all right? So one of the obvious things is creating a new guild. Same as before, we just pass in the guild that we want to create it, return the new guild. The difference here, though, is that since we're not providing our own ID, it's going to automatically generate the ID for the guild records, right? As we saw before, it's going to be a generated ID. Returning is also very useful if you want to get the ID, because when we call guild.dao.create and pass in the guild object, when it creates that guild within the table, it's going to also populate the ID of that object. And so the initial object that you pass in will now have an ID if it gets to this point here after calling this method. Otherwise, it's going to throw an exception, obviously. So when we return it, we're not only returning the guild that we passed in, but it's also going to have the new ID for the record that we just created within the table. Let's do another one. So we can do public guild find by name. So this one you can pass in a string and name, because when we created our guild class, we also have a name column. So we can do something like try return guild DAO. And this one's a little more complex. So since the name is not the primary key or the ID, we have to actually create a query for that to see if we can find any guilds that match that, specific thing we're looking for. So we can do return guild DAO.query builder. Query builder, this is going to allow us to build a custom query. And then we can do where, and then EQ for equals. And so for this, we pass in the column name that we're trying to match it to. So in this case, we'll do name. So if we go to guild, we can see that we have the name column, right? We also can provide the name itself, the actual value. And then now we can do query for first. This will look for the first record that matches that query in the table, because it can be multiple, assuming that multiple guilds with the same name is allowed, which it is in this case because we have not told it it's not allowed. Put this on a new line just so it's easier to read. And of course, we're going to catch the exception here, so exception E. And if you know anything about, writing SQL queries manually using SQL syntax, you can see that these methods here actually match how you'd write the query using SQL. So where, and then, equals, that's just simply saying, is it equal to that? So is this column here equal to this value? And then we're looking for the first one that matches that query that we're, providing, all right? And just like before, here's some other methods that are useful. So find by ID, query based on the ID, find all. So query for all is just going to return all of the records within the guild table. You have update, same as before, and then you have delete by ID. So we're going to pass in an ID, delete the guild that matches that primary key. And I'm just going to show you how to do one more thing. This one's probably a little more useful, actually. So we're going to do public foreign collection guild player get guild members int guild ID. So what we want this method to do is return a foreign collection, so basically a list of all the guild players that are part of this guild. the one that we, pass in, the ID for the one that we pass in. So first we're going to see if we can find a guild that matches this ID. So we can do something like var guild is equal to guild DAO dot query for ID, pass in guild ID. And so this will be if guild is equal to null, then just go and return null. Otherwise, we can do something like return guild dot get members. So looks like we forgot to create the method. So if we go back to guild, remember we have this field here called members. This is a really special field that allows us to automatically get essentially a list of all the guild players in the one-to-many relationship. So this will automatically match every guild player that has a foreign key with the ID of the guild that we're working with. So we just want to create a getter for that so we can just access it, because right now it's private. So we can do code generate getter, that's setter, getter, boom. So now if we go back to our service here, we can do get members. And so what that will do is try and access the foreign collection and see if we can grab any guild players and put that into a foreign collection for us to utilize. Alright, so now that we have the guild service and the player service worked out, I want to show you guys a simple command that we can make just to demonstrate what we've made so far. And then we'll test the command in-game to see if it's actually working. And we'll test everything out just to see if, the tables are created, the database is created, and everything looks good. So let's create a new Java class in the commands package. We'll call it create guild. And so what this command will be is, it's create guild. So they're going to be running /create guild, but they're also going to pass in an argument, which is the guild name. And we're going to use that guild name to create a new guild in the database using our guild service. So the first thing that we want to do is check to see if they provided the guild name properly. So if args.length is equal to 0, this means that they did not provide any arguments at all. So we want to say player.sendMessage, you must provide a name for your guild, and then return true. Otherwise, this means that they did provide a argument. So we can do string name is equal to args0. So get the first arg from the arguments list. So now let's go and get the guild player, because we need to check to see if the person who ran the command is already in a guild or not. If they are in a guild, then we're going to obviously not let them create a new guild. And if they are not in a guild, we're going to go ahead and create a new one. But first we need to also validate if the name already exists. So let's just do the first one. So do var guild player is equal to, and now we need to use the player service to obtain that guild player. So up here, we're going to pass that in. So private final player service, and then we're going to, instantiate that in the constructor. So now we can do this.playerService dot find by UUID, and then we can do player.getUniqueID.toString, because it's asking for it as a string if we do Control P here. And now we just check to see if it's null or not. So if guild player is equal to null, this means that there is not a guild player with that name for some reason. So we'll say player.sendMessage, you error, you are not in the DB for some reason. And in a real plugin, you may want to handle that differently, but that's really up to you. So we're just going to keep it simple to demonstrate what we're doing. So otherwise, the player does exist. So now we can check to see if they're already in a guild or not by doing if guild player.getGuild is not equal to null. So if it's not equal to null, this means that they're obviously in a guild. So we can do player.sendMessage, you are already in a guild. And just as a reminder, on the guild player class, whenever we get a guild player, since we already have the foreign auto refresh set to true, whenever we actually get the guild player from the database, it's also going to provide to us the guild if there is a guild, linked to that player using the foreign key. So that's why when we call guild player.getGuild not equal to null, we can know for sure that it should give us something if there is something to give. Okay, hopefully that makes sense. So otherwise, we want to check to see and make sure that the guild name that they provided is not already a guild name. So we just want to make sure that, there isn't two guilds with the same name. And actually another way you could do that is if we go back to our guild class and go to the name tag, or the name field rather, we can add another attribute to this annotation here called unique. And this should make it so that two different records in the same table cannot share the same name. So that's just another way of making sure that two guilds don't have the same name, okay? So anyway, now we're going to need the guild service to check that. So private final guild service. So we're going to do if guild service dot find by name. That's a method that we already created. Pass a name. If this is not null, this means that we have found a guild with that name, meaning that there is already a guild. So we can do player.sendMessage, a guild with that name already exists. So that's another reason to break out of this and not allow them to create a new guild. But if we made it this far, we can go ahead and create a new guild by doing var guild is equal to new guild. And it's not asking for any parameters because we did not create a constructor that would accept that. But if we go to this class, we can do that. So we can just do public guild name. Oh, that'd be a string name, right? I've been coding in too much Python. So string name, then we could do this dot name is equal to name. So that whenever we create a new guild, we can just do name. So now we've created an instance of the guild class, a new object of guild. And so now what we could do is do guild is equal to guild service dot create and then pass in guild. And so what this will do is hopefully, if there's no errors, create a new guild within the guilds table, give it an ID. And so the guild that's returned back to you should be the same guild, the same exact object, but with the ID set for it. All right. So now we can go ahead and add the player to the guild. And so the way we could do that is just by doing guild player dot set guild, and then update the player separately. So we could do player service dot update guild player. There we go. And so since guild player has a foreign key to guild, setting that field and then updating it will automatically update the foreign key and do whatever it needs to do behind the scenes. Okay. So then after all that is done, we could assume it worked if there's no exception. So we could say guild created, you are now the owner of the guild name. Awesome. Hopefully that makes sense. It's a pretty simple process. I did it step by step. First, you get the guild player, check to see if they actually exist or not, just so we can avoid any exceptions. And then we check to see if they're part of a guild or not. If they are, then don't let them create a new one. We check to see if the name provided is already a name for another guild that already exists. And then we go ahead and create the guild using the guild service, and then add the player to that guild using guild player.setGuild, and then update them via the player service, okay? And in a more complex application for this type of thing, you may want to use something called a transaction, which I'll be teaching you about in the next episode, okay? Anyway, so now that we have this command here, what we can do is also add a listener so that whenever a new player joins the server for the first time, they are automatically, a guild player is automatically created for them, so that hopefully this situation will never be reached, so that it never does error you're not in the DB for some reason, because every player who joins should automatically be given a guild player entry into the table, okay? So we're going to create a new listener here. We're going to call it join listener. So I just copied and pasted it because it's pretty simple. So first of all, we're going to be importing or just getting the player service from wherever this is instantiated. So we can use the player service within the listener itself. So in the listener, whenever someone joins the server, we're going to get the player who joined, and then we're going to check to see if the player who joined can be found by their UUID inside the database. So if they cannot be found within the database, we can assume that they don't have an actual entry into the table. So we're going to go ahead and create a new guild player object, pass in player, and what I did is I added a new overloaded constructor that accepts a player and then sets the UUID, which is the ID of the table, or for the record in the table, and then also the name based on the player. So that's a pretty simple implementation too. And then after that, use the player service to go ahead and create a new guild player. So pretty simple, so that again, every time a player joins the server, we can create a guild player for them so that they can be in the table or in the database, okay? So now we need to go back to our main plugin class and actually register these listeners and commands, all right? So we'll do that right down here. So we can do git command, create guild dot set executor, new create guild. And so now when we instantiate that, we're going to need a player service and a guild service for the constructor. So we need to actually provide that. And as you can see here, we're already creating the player service one right here, so we can just directly pass that in. So player service, but we also need a guild service, so we have not created that, I just realized. So we'll go back up here, private database dot guild DAO database dot get player DAO. There we go. And so now we can go back here and do guild service. So now we've created our new command. We can also register our listener, so we can do get server dot get plugin manager dot register events new join listener, and that is the same thing. So we'll just pass in a player service, and then we'll do this. All right, so now we can go into our plugin.yml and register our command here as well. So commands. So now what I want to do is take this plugin that we just created and throw it into the server to see if it works. All right, so there it is. So now I'm going to go ahead and start the server. And so what this should do is when it starts up, if you remember correctly from last time, it should go ahead and generate the plugin folder automatically for the plugin. Then it should also generate the SQLite server as well. So we just have to watch the console to look for exceptions, because if you configure something incorrectly with your classes for OrmLite, it will tell you. Hopefully it'll give you a error that is descriptive. But if we just scroll up here, we can see that it did create everything successfully. This is where it's giving you the logs for creating the tables and all that fun stuff. So Looks good so far. So now we can go back here and we can see that we have the folder, and then now we also have the database.db file. So looks good so far. And so let's go ahead and join the server now and see if it works. All right, I'm on the server now, so hopefully should have created a new guild player for us in the database. We can also do /create guild, and let's see what happens. So it says you must provide a name. Great. We'll say Billy Bob Johnson. It says guild created. You are now the owner of Billy Bob Johnson. So no errors. This means that it must have created the guild in the database. So now what you may want to do at this point is actually check the database itself and see what's in the tables and make sure the tables look good. So one tool that you can use to do that, I already showed you this last episode, but in case you didn't know, it's called SQLite GUI. It's a very simple and lightweight, graphical user interface application that lets you see your SQLite databases, okay? So it's pretty simple to use. So you open it up, click open, and then you just find the file for your database. So it's already right here. You can find it wherever yours is, and then click open, and then it will automatically just read the database for you, and you can see the tables here. You can see what they look like. So this guilds table has an ID, which is an integer. It's the primary key. It has a name. It's a varchar, which is just a name for a string in SQL. You have a tag, which is a string as well, and then you have a description. Then you have players. So a player has a UUID. It's a varchar, but it's a primary key. Name, varchar, guild ID. This is a foreign key, which is an integer to the guild table. So all pretty simple, pretty cool. But you may want to actually see what's inside this table. So to do that, right-click the table, do query data, and here we go. So this is the content. So we see that we have one entry, one record in the table as a UUID, a name, and then a guild ID. So the guild ID is 1. This means that there should be a record in the guilds table that has a primary key of 1. So that's what it's referring to. So if we open up the guilds table, we can see that it has it. So we have ID of 1, the name is Billy Bob Johnson, and then for the tag and description, it has nothing, and that's okay because we set those as nullable, meaning that they can be null if we want them to. So awesome, looks great so far. Now we know that everything is working. Up to this point, we went ahead and created our guilds table and our guild player table, and we established a one-to-many relationship between them so that every guild can have multiple players, and then every player is part of one guild. So now what I want to show you guys is how to set up a many-to-many relationships. This is going to be for a player achievements type of thing in the game. So for example, you know that one player can have many achievements, right? So that is one-to-many. But also you could have an achievement that many players have obtained. So it goes one-to-many in both directions, making it many-to-many. So the way we're going to do that, of course, is by making what's called a join table, or in the case of what we're doing, since we're dealing with actual Java classes and stuff like that, we're going to make another entity that acts as the join table, and then we're going to link them to our other classes, okay? So let's see how we can do that. So we already have the guild player class. This is going to be the first entity of that relationship. Now we're going to make a new achievement class. So achievement, let's go ahead and start annotating this one. So this is going to be a database table that's going to have a table name of achievements. So it's going to have a primary key, so private integer ID. It's going to have a name, so we can assume that every achievement has a name. Every achievement has a title. It could be different from the name, it doesn't matter. This is just, for dummy data. Every achievement could also have a description. I think that makes sense. And that's pretty good. That's all we really need just to demonstrate this. And so now we're going to annotate these. So database field, this is going to be a generated ID, so we don't have to worry about generating it ourselves. Database field can be null is false because every achievement should have a name. There we go. And then every achievement should have a title as well, so we'll set that to false. And then for description, we don't really need a description for every one of them by default, so we'll set that one to true. So this one can be null. And so there we go. This is the basic layout for our achievements table. So now we need to generate a noargs constructor. Generate constructor, select none, okay. And then we're also going to give it a constructor just to, make creating it a little more clean. We're going to make a constructor that accepts a name and a title. So we'll do code, generate constructor, name, title, hold control to select multiple of them, name and title, click OK. And then after that, we just need to also generate getters and setters. So code, generate, getter and setter, select every single one of them, OK. And we don't really need the set ID one. That's not really required because we're not going to be setting our own ID. So there we go. Looks good. So now we have the achievements table. So now we can go back to our database class. and go ahead and create the DAO for that, as well as the table. So we can do table utils dot create table if not exists connection source achievements dot class, and then I will make the DAO. So private final DAO achievement integer achievement DAO. There we go. And then down here we can create it. So achievement DAO is equal to DAO manager dot create DAO connection source achievement dot class. Easy peasy, right? So now how do we create the relationship between the achievements class or the achievements table and the guild player table or the players table? So again, it's going to be many to many, so we need a join table. And so we're going to create a new entity called achievement player or player achievement. Player achievement makes more sense, but what you usually do is generally just combine the two tables that you're going to be joining into one name. So if it was something like a books table and a users table, it would be like user books or books book user or something like that. So in this case, I think player achievements just sounds better. So we'll do player achievements. And so this table will not only be the join table, but also represents the relationship between a single player and a single achievement. Okay, so every record will be that. So this will be another database table, not a field, a table with a table name of player underscore achievements. All right, so we're going to give it a ID. This one can also be generated. It doesn't have to be set by us as well. So generated ID is equal to true. And now this is actually just pretty simple. So now we just need a foreign key for each of the things that we're trying to link together. So this would be just a private guild player, and then another private achievement. So again, these are not foreign keys exactly, but behind the scenes, OrmLite will create the foreign key for us and manage it for us. And so now we'll do database field. Foreign is equal to true, because it is a foreign key like I just said. Foreign auto refresh should be true. We already know what that does. It automatically provides it when we obtain a player achievements object. And then the last thing we'll do is the column name. This is not required, but you can set the column name. We'll set it to player underscore ID. And then we'll do the same thing for this one. So database field, foreign is equal to true, foreign auto refresh is equal to true, and then the column name will be achievement ID. Perfecto. And so now we're going to add one piece of extra data, some just to demonstrate that you can have data other than the foreign keys within a join table. So we'll do private date achieved. So this will be the date that they got the achievement. I think that would make sense, right? And make sure you import date from java.util, not from java.sql. There we go. So database field can be null. That's going to be false because we can assume that every single time that a new entry into this join table is established, that's when the achievement is actually achieved. So it would make sense for this to never be null because it was achieved at that point, right? So we want to set it. And so now we need to make sure that we have our noargs constructor. And then also we need our getters and setters, just like always. And we can remove the set ID. Awesome, pretty simple. So overall, I hope you find this pretty simple to understand and you understand what's happening here. So just whenever you need to obtain a achievement that a player has or get a player that's part of an achievement, you can get it through the player achievements table, okay? So now what we want to do is create a achievement service so that we can have a service specifically for any logic related to player achievements. I think that makes sense, right? So anytime you need to be like, oh, I need to grab an achievement that a player has, just go to the achievement service. It's just in its own little place. So achievement service. Oh, we cannot forget, we also need to create a DAO for that and a table. So back in the database class, let's go ahead and handle that. And let me just rename this class. I just realized I named it player achievements. It should be player achievement, singular. Because that's what it is. It's a single player achievement, right? So player achievement, integer. All right, so I've added the table creation stuff and the DAO creation stuff. I also created two getters for the achievement DAO and the player achievement DAO. So now we can go ahead and start working on the achievement service here. So in this achievement service, let's bring in three things. We're going to bring in our player DAO, achievement DAO, and player achievement DAO. because we're going to be dealing with all of those tables. So now we can create the methods part of this. So one of the methods I'm going to create is public boolean add achievement to player, just so it's more specific. So add achievement to player. So what we're going to do is pass in a player to add it to. So guild player, and then also the achievement that we want to add for the player. So this is assuming that we already have the guild player and the achievement, and you're just passing it in. And now we just want to create the relationship between those two entities or two tables. And so the way we can do that is just by doing try player achievement is equal to new player achievement. And we can do player achievement dot set guild player, and we'll do guild player, and then player achievement dot set achievement, and then finally, don't forget player achievement dot set date achieved new date. There we go. So that should just be right now. And then we'll just actually use the player achievement DAO. So player achievement DAO dot create player achievement. There we go. And also don't forget to return true. Because the reason I set it as a boolean is just because you could do this different ways, of course. Like I always say, you can just return the new player achievement that was created. That's one thing you can definitely do. Or you can just return true or false to know if it worked or not. I'm not really following much of a cohesive design here. I'm just trying to show you some basic stuff that you can do as an example, right? So there we go. That's how you can add an achievement to a player. Just simply pass in the guild player and the achievement, create a new player achievement, and then that will in turn, behind the scenes, add an entry to the join table that establishes the relationship between those two tables, okay? So now we can go ahead and add another one so this one will be a more complex example. We want to get a list of achievements that a player has. So we're going to be passing in the guild player that we want to get the achievements for. So guild player. So the way we could do this is we could do a list of player achievements is equal to, and so what we could do is query the player achievements join table and go through each of the records and check to see if the player ID matches the ID of the player that we passed into this method here, okay? So since we know that every record in the player achievement join table has both a achievement ID and a player ID, we can also just check each of the player IDs very, very easily using the queries. So we could do player achievement DAO.query builder, query builder, there we go. We can put this on a new line so it's easier to read, and we could do where, because we're looking for where something where it matches a specific clause. So where equals, and we could do player underscore ID, because that's the column that we're trying to match against. And then for this, we could do player dot get UUID. There we go. And there we go. And this is where having our column names specifically set by us is useful, because back inside of player achievement, we told it that the column name will be player underscore ID and also achievement underscore ID. If we didn't have that, we could assume that it would probably be set to something like guild player underscore ID or achievement underscore ID just by itself. But I think specifying it yourself gives you some certainty as to what you can enter into this thing here, okay? You don't have to worry about if it actually is that or not. All right, hopefully that makes sense. So anyway, once we do that query, hopefully it should return a list of achievements for that player, if there are any. And so now what we could do is say if player achievements, or just achievements is what I called it, so achievements is equal to null. So at this point, we know that we got some achievements. We have found some achievements that the player is connected to or has, right? But we have to remember, these are player achievements, not achievements. So this is the entity from the join table. So we want to extract the achievement from that. Okay, so there's different ways you could do that, but we want to essentially go through each player achievement and get the achievement object from that. So we could do a new list of achievements specifically, and we'll call this achievements actually, and we'll rename this one. Let's do that first. So let's rename this one to player achievements. And so this one's going to be achievements. I think that's more accurate anyway. So new array list. And so now we'll just go through each of them. So just a simple for loop to go through each of the player achievements. And then for each player achievement, we want to do achievements.add player achievement.get achievement. So using the magic of OrmLite, it's really that simple just to get the actual entity from the other table. So now we could say if achievements is empty for some reason, we can go ahead and return null. And then otherwise, we can just return achievements because we have done all the work we need to do. Boom, there we go. Oh, sorry, I forgot. I need to add query onto the end of this. That's how you just tell it that you're done building the query. So in here, I did the same thing for achievements, or I guess the other way around. So we're getting a list of guild players from the provided achievement because again, it's many to many, but it's one to many in both directions is another way of thinking about it. So we can provide a single achievement and then get a list of guild players from that. So we're just going to query based on the achievement ID instead of the the player ID, and then it should give us back a list of player achievements again. So then we'll loop through each of those player achievements and get the achievement from each of those, or the guild player from each of those instead of the achievements, and then add it to a list and then return it. But yeah, this is just an example of a simple achievement service that you could create. We actually didn't even need to use these, but you may need to in yours, depending on how complex it is. Now we can go ahead and create a new command just to test this all out, just to make sure that everything works. So I can demonstrate to you in game. So we're going to call this one create achievements. Alright, so I created the basic layout of the class here. So this is just going to have a player service and an achievement service, because we're going to need both of those. And so we're going to check to see if they're a player. If they are a player, we're going to go ahead and get the guild player for that person who ran the command. So var guild player is equal to player service dot get find by UUID. So player dot get unique ID dot toString. And then after that, we want to check to see if it's null again. So if guild player is equal to null, this means that they don't exist in the database for some reason. So player dot send message, you don't exist. Wow. And then we're going to return true to get them out of here. And so now what I want to do inside of this command is actually just create a bunch of dummy achievements and then add the player so that they basically obtain those achievements so that we can just see within the database if it actually works and it actually creates everything without error, okay? So we're going to create some random achievements here. So achievement 1 is equal to new achievement. And for achievements, we can pass in a name and a title. So we'll call this one first achievement. And we'll say this is the first achievement. And here's the other achievements here. So, and now we need to actually add these achievements to the achievements table, but we forgot to make a method for that in the achievement service. So let's go ahead and do that real quick. And here we go. It's a method that looks similar to the other ones that we've created so far. So you simply provide the achievement that you want to create, call create on the DAO, return it, and otherwise return null if it did not work successfully. And then we did re-add the achievement DAO as well because we do need that one, but we don't need the guild player one, okay? So we can go back to this command now and we can do achievement service dot create achievement 1, achievement service dot create achievement 2. So you definitely don't want to have this logic within a command if you're not making a YouTube tutorial, because if you were to run this multiple times, you would create the same 3 achievements over and over into the database and you'd have duplicated data. It would technically be valid because we don't have these listed as unique columns here, but yeah, you just don't want to do that because you're going to be creating data over and over. This is purely just for testing purposes, just that we can run it one time and just see if it works or not, okay? So after this, we want to add the achievements to the player. So right now, we just added the achievements, but we have not added them to a specific player. And the way we're going to do that is by doing achievement service dot add achievement to a player. We're going to pass in the guild player. We're going to pass in each of the achievements. There we go. So what this will do is actually create the record in the join table so that it stores the guild player and then the achievement ID for each of these 3 achievements in the single player that we have, okay? So yeah, that should be it. Hopefully this all makes sense. Now let's go ahead and register everything and test it out on the server. All right, there we go. So I've created the achievement service and then I've also created the create achievements command that we just created. So now let's go ahead and register that. So in the plugin.yml, we'll go here and do create some achievements. All right, there we go. So now we can go ahead and rerun this. And when we reload the server, it should hopefully call the tables utils again, so that it creates these tables that we added. And we should be able to see that also reflected in the database itself, okay? So let's go ahead and do reload confirm. And if we scroll up here, we can see that it says creating table player achievements, and it executed it, which is nice. It tells you what it ran. And also it executed creating table achievements. So, player achievements and achievements. So we created the new tables. Awesome. So now if we go back to SQLite GUI, we should be able to go ahead and reopen the database file, and it has the new data reflected, which is perfect. You can also refresh it, I think. But yeah, we can open this up now. We can see that it has no data in it because we have not done anything. But let's go ahead and rejoin the server now and try running the command. So create achievements, look for errors. No errors, perfect. So now if we go back here, let's go ahead and query the achievements table. So query data, and there we go. So we have 3 achievements. We have 1, 2, 3. First achievement, second achievement, and third achievement. Awesome. So everything is working perfectly. And then if we go to player achievements, we should see a record in the join table for every single achievement being linked to one player, just our single guild player that we have. So query data. So we have the ID for each of these records, and then we have the player ID that we're linking the achievements to, and then we have each of the 3 achievements that we are linking to that player. And then we also have the date achieved. So they have slightly different times because these are based on milliseconds, but it's all pretty much at the same time, generally speaking. So yeah, there we go. We know it's working successfully. That's how you create a many-to-many relationship using OrmLite. All right, everybody, now I'm going to show you guys how to do the last relationship in SQL, the one-to-one relationship. And the way we're going to demonstrate that is by having our guild player table, but also now a player stats table. And so we want to make it so that every guild player has only one or none player stats entry linked to it, okay? So instead of having one-to-many where it has 0 or many, this would be 0 or 1. And the way we're actually going to code that is we're going to create our new player stats table, and then we're going to create a new foreign key that links back to the guild player table. But the difference here is that we're going to make it so that it's unique, so that there can only be one record in the player stats table that has that foreign ID. And what we can also do, which is pretty nice, is we can go back to our guild player class and we can go ahead and create another foreign key relationship back to the player stats table, and this one does not have to be unique because we already have the unique property on the other one in the other direction. It's already going to be enforced, so you only have to have it on one of them. But since it's one-to-one, we can have the foreign key established in both directions, which means that whenever we have a player stats object, we can easily grab a guild player object, and whenever we have a guild player object, we can easily grab the corresponding player stats object if it exists or not. So hopefully that all makes sense. Let me actually jump into the code now to show you how you can do that. So first things first, we're going to create a new player stats class. This is going to be a database table. It's going to have a table name of player_stats. This is going to have a simple ID field, so private integer ID. And then we can also store something like the number of blocks broken. So private long blocks broken. So that's the stats that we're going to be storing in the simple example here. So database field can be null, false, and then database field generated ID is true. Awesome. And the last thing we're going to add is the actual foreign key to the guild player table. Okay, so we're going to do private guild player, and then now up here we'll do database field. This is going to be a foreign field, so foreign is equal to true. And then again, we need to set it to unique. Because this is one-to-one, it has to be unique so that there cannot be multiple records. There cannot be multiple player stats in the player stats table that references the same guild player. That would go against the whole idea of one-to-one. So there's the getters and setters, and now we can go ahead and go back to the guild player class and add the foreign key back to the player stats class, or table rather. So database field, foreign is equal to true. We don't need to set it to unique, as I said, it only has to be on one of them. And then we'll set it to private player stats. Awesome. And make sure that you add a getter and setter for that as well. So code generate getter and setter, boom. So I've created the table here, I've created the DAO, and I've also created the getter for it. So now you can, if you want to, create a player stats service, and I would do that, but this is already really long video, so I think you understand the idea of how you would do that. There's nothing different between how you'd create any of the other services and how you'd create a service for the player stats thing. The only thing I really need to show you is how to actually create the relationship, and everything else is the exact same, okay? So in one of those services, for example, you could get a guild player, and let's say that you have a method for getting the stats for that player. You simply call guild player dot, get stats, or what is it called? Get player stats. So then you can get their stats and do whatever you want with them. You can also have a method that uses that player stats object and updates it in the database, and that's pretty simple. You just use the DAO and call update. All right, so I think you get the idea. That's how you can create a simple one-to-one relationship using OrmLite. And that's it for this video, guys. Thanks for watching. Thank you, Mark, for coming up with this video idea. Y'all please let me know what y'all want to see in 2024, and I will make more videos on that stuff, okay? So now you guys should be able to use SQL relationships in your Minecraft plugins using OrmLite. You could, of course, use any database other than SQLite. Any of the major ones should work with OrmLite, but if you sat through the entire video, thank you so much, and I will see you guys next time. Alright, so that's it for this video. Thanks for watching. In the description below, I'll leave a link to the code for this episode so you can check it out. You can bookmark it, come back to it later. If you forget any concepts or you just want to review the concepts I taught in this video, I'll mark everything up with comments so you can come back and read the code without having to rewatch the video, although your reviews are greatly appreciated. So yeah, I'll leave a link for that in the description below, so make sure to check it out. And another thing is I'll leave a link to our Discord server. It's a big community for programmers. You can ask for help on your programming projects if you're stuck on something, or maybe you can get some new friends. If you don't have any friends, there's lots of people here. It's growing really fast. You can find lots of people who are passionate about the same things as you. For example, if you like Minecraft Spigot development, you can find lots of people who like that. If you like C++, if you like Java, if you like web development, it's a really, really big programming community. So feel free to join. There's a link for that in the description below. And the last thing I want to tell you is that if you want to support this channel, you can click the join button below this video, and you can join this channel as a member for as low as 99 cents a month, and you can cancel at any time. You get some cool perks like early access to all of my new videos, a cool rank on my Discord server like you see right here on the side, YouTube members, and also you get to see yourself on the screen like you see right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. And thank you. Thanks a lot. And that's it. So if you like this video, leave a like. If you want to see more, subscribe. And peace.